This video, we are going to begin our discussion of what sine and cosine functions are. But before we start, we need to see a couple of videos, a couple lessons over some geometry that you may have forgotten. You may have not, and that'll be great. That'll be a good little review for you. So the first thing we're going to focus on, there are two major triangles that show themselves quite a bit throughout the semester that we're going to use. That won't go away. You guys have hopefully seen this before in high school. Maybe you haven't. It's not a bad concept to grasp. So let's start. First thing I'm going to start with, we're going to eventually get to this 30, 60, 90 thing that's titled. First thing I want to look at, though, is if I take this triangle here and I make an equilateral triangle, which means all angles are the same. And then I'm going to call every side x, right? Because if all the angles are the same, then all the sides are the same, right? That's our equilateral triangle. So we have that. What we're going to do to create a 30, 60, 90 triangle is we're going to do a cut right there. If you see that blue dotted line, I'm going to cut it right there, which gives me this triangle. All right, so this side here is still x, right? That side is still the same, but all the other sides have changed. This side right here, right, has been cut directly in half. So this becomes 1/2 x. It's just half of x. Now I have a third side of a right triangle. I hope already in your head, or you said it out loud, this is our Pythagorean theorem, right? That the two legs, the sum of the two legs squared will equal the hypotenuse, the big side squared. So let's call this, I guess we'll call this side B. And we have the formula a squared plus b squared equals c squared. This is only true if it's a right triangle. All right, so a would be that 1/2 x squared. We don't know b, so I'll leave b. And then c is x. So we have that. I'm going to do my squares. The first, we can only really do one. I get x squared over 4 plus b squared equals x squared. All right, and then I'm going to minus that over, minus x squared over 4. If I minus that from both sides, right, this is just a 4 over 4 because it's a 1. So b squared is equal to 4 minus 1 is 3 over 4 x squared. Now the next thing we're going to do is take the square root. This would produce a plus and minus, which we'll talk a lot about later. Remember, anytime I take the square root of an equation, I get a plus or minus. But in this case, we only care about our positive. All right, so how this is going to work out is I don't know the square root of 3, so I'm going to leave it. The square root of 4 is 2, and the square root of x squared is x. So I know that this third side over here is going to be equal to the square root of 3 over 2x. So what this means is now that I have this triangle here, right, I can plug in whatever x I want. And the beautiful thing about triangles, and you may remember this from your high school stuff maybe, but we have what we call similar triangles, right? Triangles are similar if they have the same angles. The sides can be different, but we know that the ratio between the sides of similar triangles will hold. What I mean by that, so let's start with letting x equals 1. And there's a reason that x is going to be 1. You're going to see this in future videos of why we're concerned with the 1. So if x is 1, that means this side, not writing with a highlighter, this side is 1. And then the relationships hold. If this side is 1, this is going to be half of whatever that is. So if I put a 5 there, I would take half of it. If I put a 10, I'd put a half of it. So half of 1 is 1/2. And then to go from here to here, right, it just says, okay, well, you're just going to multiply by radical 3. So this is going to end up being radical 3 over 2. So the only thing, that ratio will always hold. I'll get the half down across from the 30. Notice that this is across from the 30, and this one's across from the 60. We have 3 different angles, 30, 60. This is my 90 created by this cut. So how I have this is across from the 90 is 1. Across from the 60, which is in the middle, is radical 3 over 2. And then the smallest angle, 30 degrees, 1/2. Those three sides, 1, radical 3 over 2, 1/2, you're going to see these three numbers anytime trigonometry is brought up practically in your next calculus classes and beyond. So these three values I need you to be extremely familiar with, right? Because we're going to use it a whole lot. 1, radical 3 over 2, and 1 over 2. We're going to use those three values a whole lot. I'm going to kind of show you a little bit of where we're going just to help out. We are really concerned in trigonometry with revolutions. That's really the biggest thing, is we just want to take angles. We want to do algebra on things that are spinning. So why triangles are so important in trigonometry, things spinning, is because I could take, let's say I'm going to spin, let me get off my highlighter. I'm going to spin from here and I'm going to go all the way out, right? I can go right here and I can create another triangle, right? I can put triangles anywhere it is revolving. If it revolves over here, right, I can draw a triangle and talk about how it's changing based on a triangle rather than the revolution itself. This is extremely powerful. So why we're focused with this 30, 60, 90 triangle is because when it looks like this and that degree 60 is right here, we actually get, in our revolution, we get 4 of these triangles. So we have it when it reaches, we have it when it reaches right here, and we get this triangle, right? And then I want you to notice that this is the 30, 60, 90. So I know this side is 1. It could be anything, but we're going to let this circle is called the unit circle. What that means, a unit circle has r equals 1. The radius is 1. So I get a 1. This side here is a 1/2. And this side here is a radical 3 over 2. Right? What's really nice about this, and this is why I'm setting it up the way I'm setting up, this is that first revolution gets me that triangle. But if I keep going, oops, I made a straight line. If I keep going, I end up over here, which I can create that same triangle, but it's flipped. It's still the same. The sides are going to be the same, 30 degrees there, a 90-degree angle there. This is still 1 because it's the radius of the circle, right? From here to here is still 1. But what happens is we get these sides, they're the same. I get radical 3 over 2, and I can see this if we look at it. If I take, let me grab, trying to make it super obvious for you, you can see that this side and this side, just using your eyes, they are the same length. So it makes sense that they would be the same, radical 3 over 2, radical 3 over 2 on the other side. We also get the same kind of pattern here and here, right? Those are going to be the same. So this over here, let me get back to my actual pencil or marker, whatever. This is going to be a 1/2. Here's the deal, though. This half is to the left. Remember, this is an x, y plane. So this isn't a positive 1/2, it's a negative 1/2 because it goes to the left. X's that go to the left, this distance right here, are negative. What's nice, again, is if I keep revolving around, I actually have another triangle that I can talk about, that 30, 60, 90 here. And I actually have those sides too. I have a negative 1/2. That side doesn't change. And then this side, and it's kind of hard to see, but this length is the same as this length. It's just down. So what happens is we get a negative rad 3 over 2. They're the same length, right? But one goes down and one goes up. Well, y's that go up are positive, and y's that go down are negative, right? And then we got one more thing. If I revolve further, I get to this triangle for that part of that revolution, and I get the same exact triangle now, except for now it's turned over and off to the side. Well, the 1/2 is still there. I know this side is 1/2 long. I didn't mention this over here, but these are all 1s. And then this side over here, notice that this is the same length as this, so it is still a negative rad 3 over 2 because it's down. The rad 3 over 2 are the same, so I'm going to point this out. Let me get rid of all these big markings here. And I'm going to point out all the sides that are the same. Okay, so the first one, let's do in blue. Notice that this is the same as this, which is the same as this, which is the same as that. All 4 of those sides have the exact same length. And then the other one that we'll focus on is that this and this have the same length. So we get 4 different angles that produce triangles that all have the same side. Now, we didn't talk about those revolutions, but we have big revolutions, and you can see them here. My first one would just be that 60, no big deal, right? The next one would be that all the way up here. It's the blue one. This blue one is 120 degrees, right? 60, or you could do all the way across would be 180, like all the way like this would be 180. If I minus the 60, I get 120. Or To get there, I would minus the pi over 3 to get back to 2 pi over 3. See that last video. So these are our angles, the 30, 60, 90. I need to point these out. This is 60 degrees, but it's also pi over 3. Over here, we got 120 degrees, but it's also 2 pi over 3. This angle here, okay, is 240 degrees. That's all the way around. And this is equal to 4 pi over 3. And then this last one is 300 degrees, but that's the same thing as 5 pi over 3. So you may be noticing this already, but do you see that our radians, the degrees, you'll have to memorize 60, 120, 240, 300, but you can just add 60s going around, all right? Now you'll hit this and this, but like you could still figure out where those are. One thing I want you to notice that's very important here, I know this is a lot of information, but you're going to piece it all together. The next like 5 videos just build on each other to a big picture. Anything that's like 60 degrees or pi over 3 rather, look at the highlighted in green that I have, not this one, but the other ones highlighted in green, they're all over 3, right? This is what I want you guys to memorize. This is where I'm wanting you to get. That pi over 3, or any time I have over 3 for my radian measure, I'm going to get a tall triangle. That's what I want you to memorize. It looks like this, very tall. And the reason I say tall is because I know the sides have to be one of two values. I got 1 over 2, or radical 3 over 2. Those are the only two values that show up here. The ones we're not that interested in, and that'll make more sense 2 videos from now why we want that one and why we get to choose to ignore it. So anytime I have a pi over 3, right, 2 pi over 3, 4 pi over 3, 5 pi over 3, I get what's called a tall triangle. This is the language I want you to use, and I need you to trust me with where I'm going. So anytime I use a pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, I want you to call those tall triangles. And then what that does is that tells me if it's a tall triangle, then the height is bigger than the bottom, right? Because it's tall. So if I know that it's only these two values, then I can set up my triangle real quick. It's 1, radical 3 over 2, 1/2. And since it's a tall triangle, I know that radical 3 over 2 is up top. Okay, we have another set of triangles based on our revolutions. Remember, that's the whole point, is we're trying to get revolutions down. And the way we can talk about revolutions, because we need to get to a point where we can discuss it and how it moves and do calculus on it, where you guys eventually are going to get it to it, is we change all revolutions, all rotations, get changed to triangles, right? And I pointed that out, that you can revolve anywhere you want on this circle, and I can draw a triangle like the 4 that are here. Okay, I'm not going to go through a giant explanation again, but I'm going to show you the next picture. Notice that these are all 30 degrees, but if these are 30, then these are 90, right? Those are obvious. We drew the triangles. That means that these have to be 60. So I have that same exact relationship. The small side is 1/2. The big side is radical 3 over 2. And then our hypotenuse is 1. That's the same over here. I got a 1. This is going to be a negative rad 3 over 2. This 1/2 right here, that I'm highlighting in blue, that's 1/2 down. It's the same as the one above, except for since it's going down, it's going to be 1/2, negative. Same thing over here. This going down is a negative 1/2. So we actually have triangles now for these. What I call these, let's look at the actual angles actually first. This first, if it's 30 degrees, I didn't write these in. This is pi over 6. Let's highlight these. I'm going to write them all first and then I'll highlight them. That's pi over 6. How I can get this one is I know this is pi over 6 right here, that little part. This is 6 pi over 6. So going backwards, this is going to be 5 pi over 6. I also can use the 6 pi over 6 to help me to get to the next one. That's 7 pi over 6. Right? I'm going to erase the 6 pi over 6 so I don't use it. And then if I want to find this one, I know it's a 6. And I know all the way around is 2 pi. So this is 12 pi over 6. So if I go 1 back, this is 11 pi over 6. So these 4 angles, let me highlight them so we can see them. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Notice that all of them are over 6. So anytime that I have the 30-degree angle triangle or the pi over 6, right? I guess I could put like a k here, right? K pi over 6. If I have something like that where it doesn't reduce, then I know this is going to be not the tall triangle, but we call this the short triangle, right? Because if it's the short triangle, that means that the height is the small one, and the bottom or the base, right, is the big one. So that's how I keep them straight. Pi over 3's tall triangle. And then to make it tall, I put the big side on the tall part. Short triangle, pi over 6, I do a short triangle, which means the base has to be longer, so it's shorter than the other one. I hope that makes sense. This terminology is going to be really important for the way that I describe things. If you have another way that you've learned this unit circle and you can kill it and you know it left and right, and I do want to warn you with this stuff, like we're not going to want to list out. When we get there and we do all these triangles, I don't want you to draw this big picture. And this is going to make sense here in a little bit when we get to, we have a little bit more. But these are 3690s. We have both of those. We need to memorize radical 3 over 2 and 1/2. And then we need to memorize when it is 30 degrees, it's pi over 6, which is the short triangle. When it's 60 degrees at our base, it is pi over 3, some version of pi over 3 something. And that will be my tall triangle. So I hope this is making sense. This thing can be pretty complicated. And I'm trying to scaffold you into a little bit so you can really grasp it. But this is the basis of all trigonometry. So it's very important that we spend the required time getting through here. This means practicing on your own, and I'll show you how to practice that once we get through this lesson. But it can be pretty heavy. This lesson is the lesson to pour yourself into, like work-wise, because it will make the rest of the semester much easier.